Okay, let's talk about energy. Uh, and let's do a problem. And the problem is this one. Okay, so let's say we have an inclined plane right here. Okay, here's our inclined plane. And let's say we have oops, hold on there. Let's say we have a particle. Okay, here's our inclined plane. And let's say we have a particle right here at the top, and there's no friction involved in this example, and this is theta, and it's going to be 45 degrees. And you're going to have your height right here. This is going to be your height. And your height is something you do not know, the height of your inclined plane. What you do know is that this side right here, okay, all this one right here is going to be, let me make it more specific. There you go. It's going to be 5 meters. Okay, you got 5 meters right here. And that's the length of the surface on which the particle is going to slide. So what's going to happen here? So your particle is going to slide and it's going to go this way. Okay, and you want to know what is going to be the velocity when it gets to this point over here. So let's call it point A right here. So this is going to be point A. And you want to know what is the velocity of your particle at point A. So you want to know the velocity when your particle reaches point A. And your particle is going to be at rest. So the initial velocity is going to be 0. And then you're going to let it slide. It's going to come down and it's going to hit point A. So you want to know the velocity. How are you going to solve this problem? Okay. Well, we can use energy considerations, and the energy is going to be conservative. Now, what does that mean? Well, that means that the energy is going to be constant in the whole process. So the initial energy has to be equal to the final energy. Okay. So the initial energy is going to be 1/2 of the mass, velocity, initial velocity to the square, plus potential energy, mgh, and that's going to be equal to 1/2 of the mass, final velocity to the square, plus mgh final. Okay, let's make this one a little better here. So it's going to be this m. There you go. So we have initial kinetic energy plus initial potential energy is going to be equal to the final kinetic energy plus the final potential energy. Okay, but this one is 0. So this term is going to cancel out because the initial velocity is 0. So you have mgh is going to be equal to 1/2 of the mass, final velocity to the square. But over here at this point right here, h is going to be 0, the height is going to be 0. So this one is going to be 0. So this term is going to cancel out too. So you're left with this relation. That means that all the potential energy is going to be turned into kinetic energy. And that's going to happen at point A, right here at point A. At this point, point A, all the potential energy is going to turn into kinetic energy. Well, we can get rid of the masses right here. And we have that 2 GH, and we get the square root of that. And that's going to give us our final velocity. So let's say that G is going to be 10 meters per second squared, just to make it easy. but we do not have the height, but we can get the height because we know that the sine of 45 degrees is going to be the opposite, which is the height divided by the hypotenuse, and the hypotenuse is 5 meters. So 5 meters, that multiplies the sine of 45 degrees is going to give me my height. Okay, so that's going to be 5 meters. That multiplies square root of 2 divided by 2, and that's going to give me my height. And that's going to be 3.54. So what do we have here? We have 3.54 meters. And then we go ahead and we plug it over here. So we got 2 times 10 meters over second square. And h is going to be 3.54 meters. And we got to get the square root of all that, and that's going to give us our final velocity. Okay, so we do all that math, and our velocity is going to come to, let's see, your velocity is going to be 8.41 meters over second, and that's going to be your final velocity. Okay. And what happens with the units? Well, we have here meters is going to give you meters to the square, and seconds to the square is going to be seconds to the square, and you got to get the square root of these guys. So it's going to be meters over second. The meter square is going to come out as a meter, and the second square is going to come out as a second, and you got your units over here. So that solves this problem. You have calculated the velocity of a particle that is sliding down on an inclined plane that has an angle of 45 degrees. And the energy in this case is conservative. That means there is no friction, and the initial energy has to be the same as the final energy. Okay, so we'll do more of these interesting problems. Thank you. Bye.